to bring you the cyber. Hi, this is Dogman's Time today, and I'm gonna do a video with Sylvan and Lauren to bring you the Side Behind Trampoline. And make sure to check out their STEM program. STEM stands for Science, Technology, Engineering, and Math. Now let's jump right into the Side Behind the Trampoline. The trampoline follows the laws of physics. When I jump up and down, I can calculate my total energy. Total energy equals potential energy plus kinetic energy. My potential energy is energy stored in me from things like food. Kinetic energy, however, is movement. The trampoline uses springs to maximize my kinetic energy in my jump. The trampoline also follows the simple rules of force and motion. Let's take a look at Hooke's law. Force equals the spring constant times the distance. This means the harder you put down, the higher you will bounce. The Sylvan Edge program engaged in hands-on and inspired them. Sylvan Edge program.
Sounds and identify. You hear the gentle lap of waves, the distant cawing of a seagull, but then an annoying whine interrupts the peace, getting closer and closer and closer until, whack! You dispatch the offending mosquito and calm is restored. How did you detect that noise from afar and target its maker with such precision? The ability to recognize sounds and identify their location is possible thanks to the auditory system. That's comprised of two main parts, the ear and the brain. The ear's task is to convert sound energy into neural signals. The brain's is to receive and process the information those signals contain. To understand how that works, we can follow a sound on its journey into the ear. The source of a sound creates vibrations that travel as waves of pressure through particles in air, liquids, or solids. As sounds and
Are you ready? Going through, coming down, right through, yeah. Basic underlying principles of a roller coaster start with one of the more fundamental laws of all of physics, and that is the law of conservation of energy. When we start to talk about the law of conservation of energy, what we're really dealing with is a situation that we know that in a closed system, the energy is conserved. And what that means is that energy is transformed from one type to another, but the total amount of energy stays the same. Energy is defined as the ability to do work, and so what that begs is then a definition of work. And work is the idea of moving something by using a force on it through a distance. At the bottom of a roller coaster, the object has no potential energy. The train has no potential energy. So what we have to do is we have to supply energy to the system to bring it up and give it energy. So the machine is adding energy, supplying a force. That force is moving the object through a distance, and that's what we call work. On a roller coaster, what we deal with are two basic types of energy called potential energy and kinetic energy. Potential energy is the type of energy of position, and on a roller coaster, we're talking about gravitational potential energy because we're dealing with the height that a roller coaster might attain. With kinetic energy, what we're dealing with is the energy of velocity or speed. And so as an object gains speed, it gains what we call kinetic energy. And then as we get to the bottom of the first hill, we're projected upward again by the track into another hill. At that point, we're losing speed and gaining height. And so throughout this entire process, It's one series of conversions between potential energy and kinetic energy after we do the initial work to get the system to a spot of energy that we'd like. Are you ready? Going through.
But it's off to a good start. But what about the high dive? But it's off to a good start.